Everyone. Today we're going to be looking at linear relationships. And all that is a worded problem that describes a relationship between two variables where the rate of change is constant. So what that means is that my gradient does not change, right? So my m is always going to be the same number, okay? Whether that's 3 or -10, that rate of change will not change, okay? So what this means is that we end up with a equation that kind of looks like y equals mx plus c, right? But all we do with the y and the x is we choose variables that are more suited to the question. Okay, so if we had v for volume and then time being t, we would replace x and y with those. Now, to create your linear model when you first start, you're obviously going to gain confidence as you go along, right? These are just steps that help you create that model to then find your equation, but you might get to a point in your confidence where you can jump straight to making an equation, okay? So when you read the question, the first thing you're going to do is try and identify your independent variable as well as your dependent variable, right? And now your independent variable is usually going to be things like time or maybe something like distance, if let's say we're talking about speed, right? Whereas your dependent could be something like volume, height, so on, right? Now, this is not to say that height is always going to be your dependent variable, but it could very well be. So it's really important to see what affects what in your linear model. Once you do that, you're going to draw one of your good old table of values, and that will help you find not just how to plot your line, but it also might help you find your actual rule as well. And once you have your graph and your rule, it's going to be really easy from there to answer any questions that might be asked. Let's put these steps into practice, right, and start getting used to sort of breaking down a question this way. Now, to start with, I have a hiker who's hiking at a constant rate of 4 kilometres per hour, right? And he's going to do this for 4 hours. Now, it can be a bit tricky to sort of identify that dependent and independent variable. However, your independent variable in this case, because there's nothing we can really do to stop it, it's going to be time, right? So it doesn't matter how fast or slow this hike is hiking, the time is always going to move at the same rate. And this means that our dependent variable is going to be our distance traveled, okay? So we can make these variables d and t because that makes the most sense, right? Now that we've got that, we can make our table of values and use that to sort of map out how long this hiker then makes it, right? So we're going to map this over 4 hours. We know that at the start, the hiker wouldn't have moved anywhere. So at 0 hours, he's going to be at his starting point of 0. After 1 hour, he would have hiked 4 kilometres. And then he would have done another 4 and so on and so on. Right, so sometimes it's easier to use that information and instead of making a rule to just try and put that in a table. Now that you've got your table, we're going to sketch our graph. Now, the first thing you need to do when sketching a graph is to label your axes, right? So we're replacing x with time, so t, and then we're going to replace our y-axis with distance being d. You're then going to pick the scale that best works for the graph you've got, right? I unfortunately do not have 16 lines, so I'm going to make this go up by 2. And then on the bottom here, it doesn't really matter what you choose to do as long as your scale is consistent, right? So if I'm going to use these 2 boxes here to go to 1, then I have to use another 2 boxes to go to 2. I can't then jump to 4 from 1, okay? Now that you've done that, you're going to plot your coordinates. We started at 0, 0. Our next one was 1, 4. And then we had 2, 8, and so on, so on. So if, let's say, your scale is not consistent along your axes, what that actually does is it makes you not draw a straight line, essentially, right? Your line's going to be a bit all over the place. But in this case, we can see that we would make a straight line that connects all of our coordinates. Now that we've done that, we can use this to then write a rule for our distance and time, okay? Now, in doing this, we usually use y equals mx plus c, but instead of y and x, it's going to be d and t, okay? But our c and our m are still going to mean the same thing. Now, our c is our y-intercept, which we can see here is 0, 0, okay? So if our c is equal to 0, then we can straight away say we've just got d is equal to mt, okay? Now we've got to figure out our gradient. We can see that our run across is 1 and our rise up is 4, right? It might not be to that scale, but if we were to actually look at the coordinates, we've got a rise and run of 4 and 1, okay? So our gradient is going to be equal to 4 over 1, which we can just simplify down to 4. Okay, so our rule is d is equal to 4t. We can now use that to find any answers to following questions, right? So if we wanted to find out the distance travelled for 2.5 hours of walking, we can do two things here. We can use our graph, right? So I'm going to draw a line at x equals, or at t, sorry, equals 2.5, right? And if I do that, I get to 2.5, 10, okay? So we can see that we'll end up with 10 kilometres. If we wanted to use our rule though, I'm going to replace t with that 2.5, okay? So I have 4 times 2.5, which is 10, okay? And then remember that a worded problem needs a worded answer, okay? Now, same thing for this one. I could use my graph to my advantage and go, okay, if I want to find out what happens at 8 kilometres, I can draw my line across at 8 kilometres and we can see that it would be 2 hours, right? But if we wanted to use our rule, I'm just going to replace our d with 8, and now I've got 4 times something gives me 8, so t is equal to 2. Okay, so it would take him 2 hours to hike the 8 kilometres. Now, feel free to pause the video here and have a go by yourself, but we're going to follow the exact same steps, right? We're going to start by reading the information that we're given super carefully. We can see that we initially have 60 litres of milk in this vat, and it's drained, right? So it's emptied at 10 litres per minute for the next 6 minutes, right? So what I can see is that my values are going to go down. Now, once again, our independent variable is going to be time in minutes, and we can still call this t, right? So we've got time in minutes, and then our dependent variable is going to be the volume. Okay, now that we've sorted those two out, I can draw my table of values with t and v going from 0 to 6. And we've been told that we start this at 60 litres, right? And then we've been told, well, we're being drained at 10 litres per minute. So I know that after 1 minute, I'd lose 10 litres. After 2 minutes, I'd lose another 10, and so on, and so on. So we're going to fill that table like that to our advantage. And now we're going to plot this on our graph. Once again, the first thing you should be doing is labeling your axes if they're not already labeled. Okay, so always double check for that in your question when you're given it. Okay. Now, once again, we're going to pick a scale that works for us. Okay. And I do believe that we don't have enough to go the whole way across like we did for the hiker, so we're going to end up with a bit of an awkward graph here. However, when we sketch a graph like this, we need to be really careful that we only are ever in that first quadrant with our positive values, because we can't have things like a negative volume or a negative time, right? So looking back to our table of values, we started at 60 and we ended at 60, okay? So at a minimum, if we're labeling just the 2 coordinates, we should be labeling our start and end point. Now that we've done that, we can write our rule in that form V equals MT plus C. Now our C that we found before was 60. And so now I know that I've got V is equal to MT plus 60. And now we're just trying to find our gradient. If we do that between 2 points, we know that our run across is 1, and then going down we're minusing 10. So our gradient is going to be negative 10 over 1, which simplifies to negative 10, okay? So V is equal to negative 10t plus 60, which we can also write as 60 minus 10t, okay? Whichever one takes your fancy. Now we can use our rule to answer any following questions, okay? If I want to find the volume of milk in the vat after, let's say, 3.5 minutes, well, that's when T is equal to 3.5, okay? If I had a look at that on my graph, I could see that we're going to hit 25, right? But if I wanted to use my rule to find that, we're going to replace T with 3.5, right? 10 times 3.5 would be 35. So I now have negative 35 plus 60, which is equal to 25. Okay, so it's at 25 litres after 10 minutes. We can do the same thing with our volume. We've been asked to figure out the time taken for it to reach 5 litres. I can once again draw a line across at 5 because I know that my V would be equal to 5. And I can see that's going to be at about 5.5 minutes, all right? But we can once again use our rule to figure that out. I know that, pardon me, 5 take 60 is going to be negative 55, and then divided by negative 10, T is going to equal 5.5. Okay, so it's 5.5 minutes that it takes for this vat of milk to get to 5 litres